Hello students, welcome back. In this video, we continue the topic application of Fundamental Theorem of Calculus part 1 to find the derivatives of the integrals. Here are some functions or integrals that are not in the standard form. So firstly, we will convert them into the standard form and then we will apply the FTC part 1. Let's start. Here question number A. H at x is given integral 1 e raised to power 3x square root t square plus t dt. This is in the not standard form because here the upper limit is e raised to power 3x. This is a function of x. Let us suppose that e raised to power 3x equals to u. Suppose it is u. Then h at x is equal to integral 1 to u square root t square plus t dt. Now this integral is in the standard form like f at x equals to a to x ft dt. So here now we can apply the FTC. Differentiating both sides with respect to x, h dash x equals to ddx of 1 to u t square plus t square root dt. What change you notice here? You notice here we are differentiating with respect to x, but the upper limit is u. Here the upper limit is x. So in this case we need to apply chain rule of differentiation. We will differentiate with respect to u and then u with respect to x. This will be equal to d upon du of integral 1 to u square root t square plus t dt into derivative of u du by dx. What we did here is dt upon dx. We write it as d by du into du by dx. Now this is the standard form. If here is u, then here is also u. We are doing with respect to u. So we can apply FTC part 1 on this bracket. This will be equal to h dash x equals to, apply the fundamental theorem part 1 here. This will be equal to the derivative of this u square plus u its square root into derivative of u. What is u? U is e raised to power 3x. Its derivative with respect to x is 3 times e raised to power 3x. 3 times e raised to power 3x. Next, Put the value of u here. U is e raised to power 3x whole square plus e raised to power 3x into 3 times e raised to power 3x. Sorry. One thing is here. We need to write in the square root. This is in the square root. What we did, we just substitute the value of u. U is e raised to power 3x. Next, you can write it as this is equal to 3 to 6 e raised to power 6x plus e raised to power 3x its square root into 3 e raised to power 3x. We can write here 3 times this into e raised to power 3x. This is the derivative of the given integral. 3 times e raised to power 3x plus e raised to power 3x into e raised to power 3x. Part B. Here the function, just say hx, you say it's rx equals to sin x to cos x 1 by 1 minus t square dt. Clearly, the upper limit and the lower limits are a function of x. So we can't apply the FTC part 1 directly here because we need in the standard form a to x. First we convert them, split this integral into two integrals like sin x to a 1 upon 1 minus t square dt plus a to cos x 1 by 1 minus t square dt. Next, we change the limits. This will be equal to negative a to sin x 1 upon 1 minus t square dt plus a to cos x 1 upon 1 minus t square dt. Next step, now this is the sin x and this is cos x. Still we can't apply FTC part 1. We more need to convert this one into the standard form. Let us take sin x equals to u and cos x equals to v. This is u and this is v. And what is this? This will become negative a to u 1 upon 1 minus t square dt plus a to v 1 upon 1 minus t square dt. Now these two integrals are in the standard form like a to x ft dt. Here we can apply the FTC. Here Rx was less, like this. Now differentiating both sides with respect to x, ddx of Rx, this is R dash x, is equal to ddx of this, negative ddx of integral a to u 1 upon 1 minus t square dt plus ddx of a to b 1 upon 1 minus t square dt. Now, here is u and here is v. We will apply here chain rule. This will be equal to R dash x is equal to negative d by du of integral a to u 1 upon 1 minus t square dt into du by dx plus d upon dv of the integral a to v 1 upon 1 minus t square dt into dv upon dx. We are applying here chain rule because it's the function conversion 1 upon 1 minus u square. And what the derivative of u with respect to x? U is sin x, and what's the derivative of sin x? This is cos x. So it will be cos x plus derivative of this integral according to FTC. This is 1 upon 1 minus v square, and derivative of v with respect to x, what's v? V is cos x and its derivative is negative sin x. Cos x upon 1 minus u square minus sin x upon 1 minus v square. This will be equal to minus cos x upon 1 minus sin square x minus sin x upon 1 minus cos square x. What we did? We just substitute the values of u and v. Next, by trigonometry, minus cos x upon, this one is equal to cos square x minus sin x upon 1 minus, this will be equal to sin square x. Now, one cos cancel, here one sin cancel. What do we get? Get r dash x equals to negative 1 upon cos x minus 1 upon sin x. Therefore, the derivative of this integral sin x to cos x dt upon 1 minus t square is equal to negative 1 upon cos x and negative 1 upon sin x. This completes the solution of the